All right, you ready to take some measurements? Off camera, I remeasured the height of the ball initially off the table, and it's 8.3 centimeters. So it was a little hard to do it. You know, the parallax error is something you got to be really careful about in lab. And so what I'm doing now is just making last-minute adjustments to the photo gate, making sure that where the ball is at equilibrium splits right in the middle of the photo gates. Then I'm going to add 20 centimeters to 8.3, that's 28.3, and you can see right here, I'm going to release it at 28.3. Now, again, the middle of the ball is going to be at 28.3, and then I just let it swing. So we want to take 10 measurements of the time, 0.0066 plus or minus 0.0001 seconds. So that's the precision of this precision timer. Put all those, you can add that to the top of the time if you want, plus or minus 0.001. And so the second measurement is 0.0069. 0.0068. I'm going to do 10 of them. 0.0068. Either I'm getting better or 0.0068. I must be getting better. Release it from the same spot, because you should listen to the beep. Oh, 0.0067. I was on a run there. 1, 2, 3, 4, 5. Okay, that's 6. 0.0067. 0.0064. 1, 2, 3, 4, 5, 6, 7. Okay, that's 8 of them, so I need 2 more. 0.0064. And 0.0064. So there's our 10 time measurements. Now, how do we find the velocity? Well, we're using the photo tapes taped together. Remember what the distance is between the middles of the two photo gates? Use that distance, and the time is the time it takes for the ball to go from here to here. From here to here is the time that we just measured. So obviously we'd never be able to do this with a stopwatch. Notice how this is a thousandth of a second. Human reaction time is many tenths of a second, like 3/10 of a second. There'd be no way we could do this, measure the time at that point, at that point, without using these photo gates. We could, of course, do it another way. Back in the old days, Galileo timed the pendulum swinging back and forth using the pulse, his own pulse, or the swinging of chandeliers in the cathedral. So we've progressed quite a bit more since that point. So now what you should do is we've got the height of 20 centimeters. That's the difference in the heights. You can use that to find the initial gravitational potential energy. You set that equal to the kinetic energy 1/2 mv squared. The masses cancel out. We actually don't need the mass of the pendulum for this. And you can calculate what v is through the formulas. Then compare it with the experimental velocity that we just did in this exercise.